So lesson 2, general 2D motion and constant acceleration. All right. So a cart starting at position x initial to be negative 120 meters and y initial to be negative 36 meters is propelled. So if you were to think about this, this is the position, initial position vector, okay? So if you were to like write them down, you could say R initial is equal to, right, negative 120 x hat minus 36 y hat meters, right? That's the initial position. And then it is propelled over xy plane with acceleration component. So acceleration happens to be, okay, it looks like it's a constant acceleration, but it's not a function of time here. So we're going to assume this to be a constant acceleration of ax to be positive 4 meters per second squared, right? So 4x hat, and ay happens to be negative 2 meters per second squared, negative 2y hat meters per second squared. Its initial velocity as component of, so vi is equal to, right, 8 meters per second in the x direction. So vix is 8 x hat, and 12 y hat meters per second. Okay, so these are all the initial values given to us, and we're going to try to work it out. So in unit vector notation, so I hat, j hat, or x hat, y hat, right? What is the velocity of the cart when it reaches the greatest y coordinate? So when it reaches the greatest y coordinate, it's like thinking about projectile motion here. When it reaches the greatest y coordinate, your y coordinate when it reaches maximum y, your velocity in y at y max is 0. So that's very important to understand. All right. So maybe you can write that down. At, right, y max, right, v final at y max is equal to 0. Okay. So they want us to find, right, velocity when this object has reached y max. So let's take a look at what happens in the y direction. So in y direction, okay, we know acceleration. Well, let's write down everything we know in y direction. Initial, y initial happens to be negative 36 meters. Your VIY happens to be 12, right, meters per second. Your acceleration, right, your acceleration in y direction happens to be negative 2 meters per second squared. Okay. You know your y final, Vy, right? V final y is equal to 0. Can we find time when this happens? Okay. So if we could find that time, then we can find the x velocity at this time, then we can find the velocity for both x and y. All right. So here, I can use the first equation, which is VFY is equal to VIY plus A sub y t. So we know VFY is 0, VIY is 12, A sub y is negative 2 times t. So the time when my y max happens, it happens at 6 seconds, right? To reach y max. Okay? So now let's take a look at the x direction, okay, of what happens. Well, the x direction is simply, and let's get the x here. So Vfx is equal to Vix plus A sub xt. So my Vf at 6 seconds, really, right, is equal to Vix, which happens to be 8, plus 4 times t, which is 6 seconds. So my Vfx at 6 seconds, right, is equal to 32 meters per second x hat. So I have both velocities, right? So I got my velocity final at 6 seconds happens to be 32 x hat plus 0 y hat meters per second. Okay? Now they want us to figure out what is the cart's XY position at this time. So they want to know what the R, so for part B, they want to know what R of 6 seconds is. Okay? So R of 6 seconds is really is equal to like Rx x hat plus Ry y hat, really, right? So let's figure out what's going on with the x coordinate. So xf is equal to, this is equation number 2, by the way, right? xf is equal to x initial plus vixt plus 1/2 a sub xt squared. So I want to know what my x of 6 seconds is, right? My initial position in x happens to be negative 120, right? So here is my negative 120 plus 8 meters per second for my VIX, and my time is 6 seconds, plus 1/2 times a sub x is 4 times 6 seconds squared. So if you work it out, your x of 6 seconds comes out to, I guess, negative 120 plus 48 plus 72. So your x of 6 seconds is equal to 0. Now what about your y position? Let's take a look at your y position. So your YF is equal to yi plus viy t plus 1/2 a sub y t squared. So my yf, which is y of 6 seconds, I guess, right, is equal to y initial negative 36, right? Negative 36. VIY, which is 12 times 6 plus 1/2 times negative 2 times 6 squared. Okay, so my y of 6 seconds comes out to negative 36 plus 72 minus 36. And my y of 6 also comes out to 0 meters y hat. Therefore, my r of 6 seconds is equal to 0 x hat plus 0 y hat meters as my position along the xy. All right. All right. Any questions? All right. Moving on. Number 39 on page 3. A particle has a constant acceleration of 6 I hat plus 4 j hat. Now again, make sure you understand that x hat can be represented as I hat, okay? And then y hat can be represented as j hat, and z hat can be represented as k hat. All right, so they can be interchangeable. So a particle has a constant acceleration of this much. Okay, so it's good to know. So here, my acceleration is equal to 6 I hat plus 4 j hat meters per second. And my velocity vector, initial velocity vector, happens to be 0 I hat plus 0 j hat meters per second. I forgot the square here, sorry. Like that. And my position vector, initial position vector, happens to be negative 10 I hat plus, plus 0 j hat meters. Okay. So, part A, find the velocity, speed, and position of the particle at 15 seconds. Well, how do I find the velocity at, right? Let's take a look at what's going on then. In the x direction, right, so time is 15 seconds. So let's take a look at it in the x direction. We know Vfx is equal to Vix plus a sub xt. So here, when t is equal to 15, my v of 15, right, you could say, I guess, right, Vx at 15 seconds is equal to Vix, which is 0, plus AX, which is 6, times 15. So my velocity in the x direction at 15 seconds comes out to 90 meters per second I hat. And then in the y direction, my VFY is equal to VIY plus A sub YT. So here, my Vy at 15 seconds is equal to 0 for my y velocity initial, right? And then plus 4 times 15. Therefore, my velocity in the y direction at 15 seconds comes out to 60 meters per second j hat. So you can say my velocity final at 15 seconds is equal to, right? You can say 90 I hat plus 60 j hat meters per second. Okay. Then they want the speed, right? Well, I'm going to say that this is A. This is A. B, they want the speed of this, which is just the magnitude of my velocity at 15. Right? And we all know how to do that. That is just square root of 90 squared plus 60 squared, right? So the speed is equal to, I guess you get something like 108.2 meters per second. Then it wants the position. So for part C, they want R of 15 seconds. Okay, that's what they want. So, Rx I hat plus Y hat. Okay? So you could think of Rx as just being X, right? So you could say Rx is equal to just X final, right? So let's do that. So for the X direction, we have X final is equal to X initial plus Vix t plus 1 half A sub X t squared. So here, your X at 15 is equal to, right? X initial is negative 10. Right? So negative 10 plus initial velocity in X is 0. So this whole term goes to 0. Plus 1 half times AX is 6. Right? 1 half times 6 times 15 squared. Because you wanted time to be 15. So if you work it out, your X position at 15 seconds comes out to 665 meters. And then for the Y direction, your Y final is equal to Y initial plus VIYT plus 1 half A sub YT squared. So your Y of 15 is equal to initial position of Y is 0. Your initial velocity in Y is also 0. Right? Plus 1 half times A sub Y is 4 times 15 squared. So your y at 15 seconds comes out to 450 meters. I guess you could say j hat. I could say this to be I hat. So if you want this in terms of your position vector in 15 seconds, it comes out to, right, 665 I hat plus 450 j hat meters. All right, any questions? Alrighty. Now, we did page 4 already, I believe, yes? Most of you should have page 4 done. So we can move on. All right. So a cargo plane is flying horizontally at an altitude of 1,200 kilometers with speed of 900 kilometers per hour. So this plane is flying horizontally at well, let's just say this crate was dropped off like way back here. All right, so it's going to actually fall down eventually from here. So this is your initial starting position, okay, where the crate was dropped off, okay, and it's going to basically hit the ground right here somewhere, sometimes later. When this thing actually is dropped, right? So when it falls out, this is a very important thing. When crate falls out and is flying horizontally, right? Right? You have to assume that the initial velocity in the y direction is 0 because this crate only had horizontal velocity when it was released from the airplane. The horizontal velocity is this Vix is exact same Vix as the airplane. And this airplane will remain at that VIX constantly straight through. Okay? So as this airplane continues on, as soon as this thing is dropped, this airplane and the cargo would stay right next to each other, but get further and further separation vertically. So this crate should be right underneath the airplane as long as this airplane is going at a constant velocity, like so. Okay? Just keep that in mind. So here is your initial x right here, I guess. X initial. We're going to call that 0. And this is your x final. Okay? Which we don't know, actually. Here is your y initial. This is your y initial. And your y initial is 12 kilometers or 12,000 meters. And your y final is 0. Okay? Your VIX is 900 kilometers per hour. It's probably a good thing to convert this into meters per second because our acceleration due to gravity will be given to us as 9.8 meters per second squared downwards. So it's good to change everything into meters and seconds and so on. Okay? So here in 1 kilometer, there are 1,000 meters. And in 1 hour, there are 3,600 seconds. So we can actually cancel out the kilometers, cancel out the hours, giving me meters per second. And if you do this, hopefully correctly, you get 250 meters per second. So this 250 meters per second is exactly how fast this crate is traveling horizontally when it's released in the x direction, 250 meters per second as well. And here it's going to be traveling 250 meters per second. And here it's going to be traveling 250 meters per second. And here, right before it hits the ground, it's going to be traveling 250 meters per second. Horizontally, my velocity will not change. Okay? All right. So now we can actually start the problem. So how long does it take the crate to hit the ground? So they want us to find time. So for part A, they want us to find time. To find time, 95 to 98% of the time, you're going to use y direction. All right. Let's take a look at y direction. We know, right, initial velocity in y is 0. Okay, that's good to know. So let's write down everything we know. We know VIY is 0. We also know a sub y, which is g, which is negative 9.8 meters per second squared. We also know y initial to be 12,000 meters. We also know y final is 0. And I'm looking for time. So we could probably use the second equation, right? Equation number 2, which is y final is equal to y initial plus VIYT plus 1/2 a sub yt squared. So since my y final is 0, my y initial is 12,000 plus y VIY is 0, right? Plus 1/2 times negative 9.8 times t squared. So if you solve this out, right, you're going to get t squared is equal to negative 12,000 over negative 4.9, right? And that is equal to 2448.97. So your time comes out to 49.5 seconds. All right, so that's part A. So part B, how far horizontally is the crate from the point where it fell off to where it hits the ground? So they want to know what this is. They want to know what this delta x is for part B. So for part B, they want to know what delta x is, or simply x final, right? Well, we know the time. So let's write down everything we know. We know Vix is equal to 250 meters per second. We also know that a sub x is 0 because there's no rocket engine attached to this crate to make it accelerate horizontally. We're also going to assume there's no air resistance or wind anywhere, or headwind or tailwind, so there's no acceleration in the x direction at all. We also know one more thing, which is time. Time is equal to 49.5 seconds, and the x initial is 0. So can we find x final? And the answer is yes, we can. Right? So here, my x final is equal to x initial plus Vix times time plus 1/2 a sub x t squared. So I'm looking for my x final at time is equal to 49.5 seconds. So my x of 49.5 seconds is equal to x initial is 0, Vix is 250, and time is 49.5 plus AX is 0. So this goes to 0, and this goes to 0. So my X at 49.5 seconds, which is pretty much the X final, right, is, I believe you get 12,375 meters. And then for part C, they're asking, how far is the crate from the aircraft when the crate hits the ground? Well, when the crate hits the ground, the airplane is right above it. So your airplane is going to be right above it. So what happens? Well, it's going to be right below. So what is the separation? The separation is just the altitude. Right? The separation is going to be the altitude of 12,000 meters. Right? So air resistance. Okay, the crate is directly right below the airplane, right? When the crate hits the ground. Therefore, 12,000 meters. All right. All right. Then, um, what would happen, just for fun, to extend on this? What would happen instead of just releasing it or just dropping it from the back of the plane? What if you like actually threw this thing downwards from the plane, like shoot it downwards, or like let's say you like shoot it upwards, right? How would that change the problem versus just like releasing it from the plane, right? Keep that in mind. Think about that. Hint, hint. Look at the stars. Must be important. Umar gets it. All right. All right. Any questions? All right. Good. 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 Very good. Let's take a look at the next problem on page 6. Very similar kind of problem here. All right. So a stone thrown horizontally. Ooh, again, horizontally. When stone is thrown horizontally, that means it should automatically set you off here where your V initial in Y direction is 0. That's a huge clue, okay? So from a top of 24 meters tower. So this is your Y initial, and your Y final is 0, okay? And this is your X initial, which is 0, and this is your X final, right? Which is equal to 18 meters. Now, obviously, when this thing is thrown horizontally, it will have initial velocity in the x direction. Well, that initial velocity in the x direction is your v naught, because it just happens to have only the x component, and y component is 0 initially. So your v naught is your vix. Okay? All right. And this vix will stay the same value throughout the whole trajectory, whole trip, right? So it will always be the same VIX, right? VIX, 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 right? VIX. So find the speed at which stone was thrown. So they want you to find your V naught, which is your VIX. All right. So let's do that. Let's do that. So for part A, they want you to find your VIX, which is V naught. To do that, we need to find time first. Okay? So find time first. Well, to find time, you really should use the y direction. So because we know, right, VIY is equal to 0, you know your a sub y, which is negative 9.8, right, meters per second squared. You know your y initial is 24, and your y final is 0, right, because g and ay are the same thing. We can find time. Let's use the second equation, which is yf is equal to yi yada plus VIYT plus 1 half a sub yt squared. So here, y final is 0, y initial 24, VIY 0 plus 1 half times negative 9.8 times t squared. So if you solve for t, right, your t squared happens to be then negative 24 over negative 4.9, right? So your t is equal to 2.21 seconds. Now that you found your time, we can use the same equation in the x direction. Your x final is equal to your x initial plus VIX times time plus 1 half a sub x t squared. We know a sub x is 0, right? We know a sub x is 0. So this whole term drops out to 0. Your initial position in the x direction is 0. So your x final at 2.21 seconds is equal to your VIX, right, times time. Well, we know this. This is 18. VIX, we don't know. We're going to have to find that. Your time, 2.21. So your VIX is equal to 8.14 meters per second xf. And that is your V naught. All right. All right. What about part B? Part B asks, find the velocity in component form and, so, well, that's easy actually. Right? Let's find the velocity in a component form and the speed of the stone just before it hits the ground. So when this thing is actually right before it hits the ground, it's still traveling. So this is your VF right before it hits the ground. And we're not looking at it where the stone hits the ground, the dust goes up and then settles down. And then we're looking at it before the first atom of the stone touches the first atom of the ground. So it is moving. It's technically moving. We're not looking at this once the dust settles. All right. So this VF is going to have a VIX component or VFX component, right? So this VFX is your VIX. We already know this. This won't change. However, your VFY, we have to calculate because that will change depending on time. And this is your theta final, which is the approach angle of the projectile. So we're looking for VF, right, when time is 2.21 seconds. And that is simply, right, VIX x hat, right, plus VFY y hat. I mean, you could put this as your VFX too, because it doesn't really matter. It's the same thing. Your VFX is your VIX, right? So we already know this, but we don't know this, right? So we could say, okay, let's find the VFX then. So VFY at 2.21 seconds is equal to VIY plus A sub YT. Here, your VIY is 0. Your A sub y is negative 9.8 times time, 2.21 seconds. So your VFY, which is at 2.21 seconds, is equal to negative 21.7 meters per second y hat. And again, we said VFX is equal to VIX, which is equal to 8.14 meters per second x hat. We already know that. So we can write our VF right before it hits the ground, which is 2.21 seconds, is equal to 8.14 x hat minus 21.7 y hat meters per second. So that's part B. Well, part B has a lot of parts. Okay. So they want us to figure out, what's the speed of this John. All right. So, well, that's easy. The speed of this VF magnitude, right, is equal to basically square root of, right, 8.14 squared plus 21.7 squared. So if you work it out, the final speed before it hits the ground comes out to 23.18 meters per second. Then you can figure out the theta final, which is tan inverse of. Always use the velocity vectors to find direction, because velocity vector tells you the direction of motion. All right, is equal to VFY over VFX. Therefore, your theta final comes out to, right, tan inverse of VFY, which is negative 21.7. Divide that by VFX, which is 8.14. And your theta final comes out to negative 20.6 degrees. So your final velocity can be represented in polar form as 23.18 meters per second, comma, theta is equal to negative 20.6 degrees. I guess for this one, your initial velocity here, if you want to, you could always say that is equal to 8.14 x hat plus 0 y hat, right? Meters per second. All right. All right. Those are fini. Any questions so far? All right. Let's take a look at page 7. Page 7, a projectile is fired into the air from top of 200-meter cliff above a valley. Its initial velocity is 60 meters per second at 60 degrees above the horizontal. Where does the projectile land? So they really want to find out what this x component is. Right, so here's your x initial, which is 0, and they want to know what the x final is, right? And since you're looking for range, first thing people will do is, oh, wait, we have equation for this, range equation. We cannot use range equation for this because this is not on a flat ground, okay? And then some people are going to say, well, can we just find out how far it's going to go and up like this and then figure out the rest? That's just going to make it a lot harder for you. So don't use the range equation unless your delta y is 0. And since your delta y is not 0, your delta y is negative 200. So here's your y initial, which is 200 meters, and your y final, which is 0 meters. Okay? So when you fire this thing at 60 degrees, it's always a good idea to figure out the components of your initial velocity. And since your V naught, which is your muzzle velocity, happens to be 60 meters per second at 60 degrees above the horizontal, this will have your VIX, and this is the launch angle right here, theta naught, and it will also have your VIY, which is your vertical initial velocity, okay? So VIX is adjacent to my angle theta, so it is V naught, right? Cosine theta naught. So my VIX is equal to 60 times cosine of 60 degrees. So my VIX comes out to 30 meters per second x hat. My VIY, however, is equal to V naught sine theta because it's the opposite of my angle theta naught, right? So that is equal to 60 times sine of 60 degrees. So my VIY is equal to 52 meters per second y hat. Crap. The whole classroom light just went off. I guess the timers, or wow, that was really freaky. The whole classroom light went off. Okay, so now that we figured this initial velocities and the x and y components, okay, always look for time first. Okay, so find time first by using y direction. Like I said, it's not always the case, but most cases you'll be using the y direction to find time because you know acceleration, right? You know height, a lot of things. Once you know the height, you could most likely use y direction. So if we use the y direction, your y final is equal to y initial plus VIY times time plus 1/2 a sub y t squared. Your y final is 0. Your y initial is 200 plus y initial, VIY is 50, 52, sorry, 52 t plus 1/2 times negative 9.8 times t squared. Wow, this looks very, very familiar, right? This is, right, 4.9 t squared minus 52 t minus 200 is equal to 0, right? And I know you probably asked yourself when you were learning quadratic equation in Algebra 1 in 6th grade, you probably said, when the hell are we going to ever use this stuff? Well, here it is. You must use quadratic formula to solve for time. And when you do that, your time comes out to 13.61 seconds or negative 3.0 seconds. Now, obviously, you're going to take the positive time because if you actually take the negative time, either you should win a Nobel Prize or you did something wrong. And the chances are you did something wrong when you use negative time. All right? All right. So 13.61 seconds is how long it takes for this projectile to hit the ground. All right. Now that we know that, we can probably figure out how much distance it travels horizontally. So we can say my x final is equal to x initial plus VIXT plus 1/2 a sub x t squared. Well, we know a sub x is 0, right? We always know that. We also know the initial position in the x is 0. So my x final at 13.61 seconds is equal to VIX, which is 30 times 13.61 seconds plus 0. So my x final, 13.61 seconds, is equal to 408.3 meters. All right. Just for fun, let's go back to this here. If we were to, instead of firing it 60 degrees above the horizontal, let's fire this thing 60 degrees below the horizontal. If we were to do that, what changes? Well, the horizontal velocity initial is going to stay the same. However, your velocity in the y component will be negative 52. If that's true, then this equation becomes 200 minus 52t, right, plus 1/2 negative 9.8 t squared. So when I bring this to the other side of 0, then it becomes positive 4.9, and this becomes positive 52, and then negative 200. Guess what happens? The sign switches. where this becomes negative 13 and this becomes positive 3. Just a fun fact. All right. All right. So you should be able to figure out exactly what's going on at any of these locations at any time. You should be able to figure out, what the final velocity is at this point, and time is like 12 seconds, or when time is 7 seconds, and etc., etc. You should be able to figure out the speed of this projectile and the height of the projectile from the ground at any time from using this. All right. Any questions? All right. Moving on. It's hockey season. Oh, well, it would have been hockey season, I guess. Here we go. Let's take a look at hockey. Okay. Suppose that a hockey puck is struck in such a way when it is at its highest point, it just clears a plexiglass wall of height h is equal to 2.8 meters and the horizontal distance of 12 meters away. Find the VIY, the time to reach the wall, the VIX, the initial speed V naught, and angle theta for this case. Common mistake people would make would be, wait a minute, I know the horizontal distance here is 12 meters, and I know the vertical height happens to be 2.8 meters. Can't I just use tangent to find the theta here? And the answer is no, you cannot. You have to use velocity in order to find the angle theta. You cannot use position to find theta. So please make sure you understand that. And since this V naught right here is what we're supposed to find eventually, I guess, right? So here, this is your horizontal initial velocity, VIX, and this is your initial velocity in y, which is VIY, and this angle here is your launch angle theta naught, not 12 and 28. Okay? All right. Oh my God, I only have 2 minutes left? No, 5 minutes left? All right. Gotta hurry. So here at the Y max, so VFY max is equal to 0. That's a very important thing to know. Okay? So for part A, we can use VFY squared is equal to VIY squared plus 2A sub y delta y. I can use the third equation. Why? Because I know my VFY at y max is 0. And I can find the VIY because I have other ingredients here. A sub y is negative 9.8 and delta y is 2.8. So if I solve for VIY, my VIY just happens to be square root of 54.88, which comes out to 7.4 meters per second y hat. Well, how much time does it take? If we take this and find time to reach that, right, 0, from here to 0, we could probably find time from here to there. So for part B, I can use my first equation. here, this is 0. My final velocity at y max, 0, is equal to VIY, which we calculated to be 7.4, minus 9.8 t. And if we solve for time, my time comes out to 0.755 seconds. Once I find that time, I can use that to figure out how much velocity I have in the x direction traveling 12 meters at this much time. Okay, so I can use x final is equal to x initial plus VIXT plus 1/2 a sub xt squared. Once that hockey puck leaves that hockey stick, there's no more acceleration. Okay, there's no more acceleration. Therefore, my x final is 12. This is 0 VIX times 0.755 plus 0. So my VIX is equal to 15.9 meters per second x hat. So now we have all the ingredients to get for V naught, because here's my V naught, right? Here's my VIX, and here's my VIY, and I could calculate my angle theta naught and my V naught, right? So my V naught, which is part D, is equal to square root of, right, 15.9 squared plus 7.4 squared. So my V naught comes out to 17.5 meters per second. And theta naught is equal to tan inverse of VIY over VIX. So my theta naught is equal to tan inverse of 7.4 over 15.9. So my theta naught is equal to 25 degrees. All right, that's the bell.